Okay, guys, it's lesson 7-1 or 7-1. Remember, again, as always, don't copy my work. I'm seeing some of you guys still copying my work. So please, as you guys go through this, do your problems, not the problems that I am showing you. Okay, guys, just adjusting my webcam here. Okay, so let's start off. These are all log. Okay, this is all types of log problems. We're using log to solve these. All right. Now, when we're dealing with this type of problem, with the exponential problem, the first thing we want to try to do is make a common base. So what I mean by that is, like, let's say I have 5 to the x equals 25. What I would do is I would change this 25 so that it has the same base as the number on the left. So this still 5 of x. 25 is the same as 5 squared. Notice how they have the same base now. So that must mean that x equals 2, right? So that would be a simple way to solve that. But if you notice, with these problems, I can't change this 3 to be the base of 1.17, or I can't change this 12 to be a base of 3, because there is no power of 3 that equals 12, or at least no whole number power, right? Okay, so what we're going to do is use log to solve these. So what you do is we're going to basically go from, we're going to go back and forth from log form to exponential form, but also from exponential form back into log form. And if you guys remember that if I have a log base b of a, which equals e, I can change that back and forth from that to exponential form, where the base is this number here, the b. E is the exponent, and you make it equal to a. So you notice how these are all in this form, that exponential form like this. So we're going to go back to log form like that. So here, log of b, the base, which is 1.17, and the a value is the 3. So put that here in parentheses. Okay, and we set that equal to the exponent x. So now all I really have to do is plug this in. So let's set that up for all of these, actually, so we can just plug it, so we can calculate them all at once. All right, so this would be log base 3 of 12 equals x, and then same thing here, log base 4 of 7 equals x. Okay, so now what we're going to do is set all these up in the calculator. All right, so you can use the Desmos calculator. Now, here's the thing with this one. This one, the scientific, does not do, will not let you change the base. So if I go to function here, all it has is log. It doesn't have the log like with the b, which lets you change the base. So go to the graphing calculator version of this. And if you go to scientific calculator, you can just click on this and click graphing, or just literally search Desmos and then graphing calculator. Okay, so what we'll do, let me hide this, is open the tools and go to functions here. And then you have to go to miscellaneous, and then you'll see the regular log, which is, remember, if there's no number there, that means it's a base of 10. But we don't want base of 10. We want to be able to change the base. So we use the base of a there. That allows you to input a base. Okay, so the first one was 1.17 of 3. Okay, so what I'm going to do is I'm basically going to type all these problems in here at once. So here I'm going to have to, again, select that function. Oops, I need to do a new line here. Okay, so let's select that new function here. So log, the next one was log base 3 of 12. Okay, and then down here, let's do another one. And this will be the last one, which is log base 4 of 7. Okay, so I got all these values. So what I'm going to do, when you do log, typically you do it to like the thousandth. Let's see what this is actually asking for. Oh, you notice it says it's once accurate to 2 decimal places. So it wants us to round to the nearest hundredth. Okay, so that first one, we're going to put 6.997. I looked at the 7, which is going to round up to 9. So we're actually going to round this up to 7.00. Okay, so x equals 7.00 for the first one. You can see I wrote it there. Okay, so then the second one will be 2.26. Because that one's not going to round up to 6, so 2.26. Okay, and then the last one here, we're going to round to the 0 spot, so the 3 will not round that up, so it'll be 1.40. Okay. All right, so this one we pretty much treat the same way, except the only difference is that in the exponent part of the problem, you've got an expression, okay? And you're still going to handle it the same way. We're still going to put in log form. So we'll have 4.925 as our base here, and the a value be 110, and we're going to make it equal to x plus 1. And let's do the same thing over here with this one. So log base 12 of 156 is going to be equal to, oh, I apologize, guys. There's one more step we actually have to do with this one. So let's actually come back to that one in a second. Okay, so here, x needs to be isolated, okay, because I've got this plus 1. So what I'm going to have to do is I'm going to have to subtract 1 from this side. So essentially what that means is I'm going to have to do the log base 4.925 of 110, and then after that, I have to subtract 1. Okay, so I'm going to have to plug all that in to figure out the solution there. So let's close these out. All right, so again, I'm going to have to select the one that allows me to change the base, 4.2925, 110, and then outside the parentheses, make sure you do it outside, I'm going to put -1. So it's going to be, and if you notice, this one actually wants us to round to the nearest thousandth, okay? So the nearest thousand, 3 decimals after, or 3 numbers after the decimal. Okay, so we'll round, that means we're going to go to the 8. The 2 will not change the 8, so it's 1.948 is our solution there. All right, yeah, I wanted to hold off on this one because there's an extra step here. Before I change this into log form, I want to isolate the base and the exponent, which means this 12, I've got to get rid of it. Now it's being multiplied, so that means we'll do the opposite and divide. Okay, so we'll divide here. Okay, 156 divided by 12 is going to be 13. I know that because 144 divided by 12 is 12. So I just had to add one more. Okay, so now let's change that into log form. And with the base is going to be 1.3. The a is going to be 13. And we set that equal to 3x plus 2. So you notice now, not only are we going to have to subtract 2, we're also going to divide a 3. So let's subtract 2. You can see I left a little space there just so I could kind of draw that 2 in, -2 in there. Okay, so now log base 1.3 of 13 minus 2 equals 3x. And now the last step is we've got to divide this 3. Okay, so we got to enter that in. All right, so now let's enter that in. So we're going to have, again, select that option, 1.3 of 13. Oops, sorry, I didn't get it inside the parentheses there. Okay, and then -2. And what I'm going to do is I'm going to put all of this in parentheses to make sure I'm dividing everything by 3. So it looks like that. So make sure it looks like that when you enter it in. Okay, so it's going to be 2.59. Does the 2 round up? Nope. 2.592. Okay. All right, so same thing here. Pretty much the same thing, just like the first one's up here. So we're going to do log base 3 of 4 equals x. Okay, set that up in here. Get the function, log base 3 of 4. Okay, again, this one also is rounding to the nearest thousandth, so 1.261, and we have an 8 this time, so that's going to round the 1 up to a 2, so x equals 1.262. Okay, and again, all these problems are pretty much like the same thing, like over and over again. Okay, so this one you're going to solve the same way, log base 6 of 32, and just enter that in. Okay, so I'm not going to solve that because that's literally the same thing we just did. This one's a little unique because it's a fraction, and you notice how the exponent, the x, is in the denominator. We don't want it there. So what we're going to do is we're actually going to move this up using our negative exponent rule, and we move that up. Now that the exponent just becomes negative. Okay, and then we put it in log base form. So log base 6 of 32 is now equal to 1x. And I want to emphasize that's a negative 1 because before we finish, we're going to need to multiply both sides by negative 1 or divide by negative 1. I'm going to multiply by negative 1, okay, because negative times a negative will cancel out that negative there. Okay, so the way I would enter this now is, let me do negative 1. I'll put parentheses, and I'm gonna put the log inside of that. Oops, that was the wrong function. This one. Okay, so log base 6 of, what was that, 32. Just want to make sure it's inside those parentheses there. And that's it. Okay, so let's be negative 1.934. Okay. And since I'm here, I'm going to go ahead and just erase that because that's literally the problem we just did, was log base 32. So that was the one we did there where I flipped up the negative, became the negative exponent. And then that was the one before. If you notice, it's almost the exact same thing. It's pretty much the same thing, just with the negative. So it's going to be that same number. So I'll go ahead and write that in. So 1.934. Okay, and you're going to get similar results as you go through these. Okay, now what we're going to have to do here is we're going to flip this up. All right, sorry about that. Okay, so we're going to flip that up. So now we have 32 equals 1 over 6 to the x power. Now we're again going to use the negative exponent rule. Okay, so that means that'll be a negative x. And then we're going to use the negative exponent rule again. So inside the parentheses, right inside there, I'm going to move that 6 up to the top. So just inside the parentheses, though. So I'll move that up to the top, and I'll show you what that looks like. Okay, so basically that's 6. I'm going to move it up to the top, and now it's 6 to the negative 1. So sorry, I know that's a little tough to see. Move in a little bit here. Okay, so you can see it's 6 to the negative 1 now, and then that negative x is still on the outside. So now what I can do is I can distribute that negative x to the negative 1. So, and when you do that, remember, it's the power of a power, you multiply it. So negative x times negative 1 is positive x. Now, doesn't that look familiar? That's literally the same thing we started with over here. So we already know the answer to that problem. So I'm literally just going to write in the same answer from the first problem, because that's literally the same thing. Once I kind of simplified this and rearranged it by using the negative exponent rule, it ended up being the same problem as the first one. Okay, so it says show how this expression here, 1 over 6 to the x, is equal to 6x. Okay, so I'm going to do that, showing you with this. So that's pretty much what we just dealt with in this last problem. So it's almost like they just want us to show how that is equal. Okay, so again, I'm going to move this up. So now it's 1 over 3 to the negative x because I moved it up to the top. Okay, and then again, I'm going to move that 3 to the top. So now it's 3 to the minus 1. And again, this is good practice for you guys to be able to see what I was doing in the last problem. Okay, and that's equal to 3x, 3 to the x. And then again, we're multiplying these because it's the power of a power. And it's a negative 1 times negative x, which would be positive x. So you can see that they're equal. So boom. All right, so it's just saying show that this is equal to that. So you would work that out. Okay. All right, so now these next ones. I'm move myself down a little bit so I'm out of the way. All right, so here we're basically evaluating this. Okay, it says evaluate without using a calculator. Okay, so the way we're going to do that, let's see here, x. Okay, is we're going to just put this in exponential form. Okay, and we kind of have to use our rationale to figure it out. So first, let's go back to exponential form. So 6 is the base, x is the exponent, and we're going to make it equal to 1. Now, if you raise a number to a power, to some number, and it equals 1, the only power that you can raise a number to where it equals 1, unless it's 1 itself, is 0. So that means that in order to get 1 here, I'd have to raise 6 to the power of 0. And any number you raise to the power of 0 is going to be equal to 1. So what that means is that x equals 0. Okay? Okay, so now on this one, we're going to, since there's no x here, you notice how I wrote it in an x, right? Because we're trying to figure out what is this equal to. So we don't know what it's equal to. So for all of these, I'm basically setting them equal to x to help me solve these, okay? All right, so now remember, if there is no base here, that means that the base is automatically a 10, right? Okay, so this 10 to the x, I'm going to put this in exponential form. 10 to the x is equal to 10 squared. If they're the same base, that means x equals 2. Okay. All right, so now with this one, what we're going to do is now we're going to put it in log form. So this would be log base 10. The a is here, so that just goes here. And then the e is all of this. It's the log of 3. So the log of 3 is the e, so that remember when you go into log form, the e goes on the other side of the equation. Now, this is base 10. This is automatically base 10 because it's not written. And when you have a log, a single log on both sides, that means that these a's have to be equal. So I can just basically cancel these out and x equals 3. Okay. Now we're going to do a similar thing here. Okay, so here, start with log base 10, okay, of x, that x there, equals, okay, equals this, the 2 times log of 3, all right? And now what we're going to use is we're going to use some more rules. If you guys remember, our power rule. Our power rule says that if I have an exponent here, I can move it to the front. But I can also go back the other way. So I can take this number, if I'm multiplying the number times log, I can move it back up here to the exponent. So now this stays the same. This now is log base 10. Remember that it's automatically base 10 of 3 squared. So now, just like this problem, I have a log equal to a log, so I can cancel them. And now x equals 3 squared, which is 9. Okay? All right, now this next one. This next one, again, we're basically using, we can use a calculator, but don't use the log button, okay, to solve, because we've already figured out what the log of 2 is, log of 3 is, and approximately what log of 5 is. So we're going to use this idea in order to solve these ones here at the bottom, okay? So let's just say for this one, I'm going to rewrite for this one. I meant this one. Log of 5. Actually, I don't like that one. Log of 5. Why did I do that? Let's do log of, let's say, let's do log of 9. Okay. All right. So what we're going to do is you want to look at these numbers and look at them like they're factors of the numbers inside here. Okay. So how can I split 9 up to be equal to, so that both of those numbers that I split them up into are one of these, either the 2, the 3, or the 5. And I'll show you what I mean by that. I know that 9 is also 3 times 3. Okay, so 3 times 3 gives us 9, right? Now, if you remember, the product rule allows us to take a log that has 2 numbers being multiplied on the inside and split them or expand them by adding 2 logs together. So basically, it's going to be, I can split this into 2 different logs and add them together. Okay, so now I've got log base 10 of 3 plus log base 10 of 3. Because again, basically I take this number and I split it into numbers that I know. So think about it. What could you multiply to get 6? I'll give you a hint. 2 times 3. And then split that. Now, what we've already done is they've already calculated the log of 3, which is this 0.4771, and this is going to be the same thing because it's also 3. And now I just add these up. Okay, so I'm take out my calculator here. Let's add up 0.4771 plus 0.4771. Okay, it's going to be 0.9542. This is equal to 0.9542. All right, so now we're doing do the same thing with 10 here. How can I split that up for the factors to be either a 2, 3, or 5, or a combination of 2, right? Well, I know that to multiply 10, I can multiply 2 times 5. So I basically split up the 10, and I know that 2 is, we have the log of 2 and we have the log of 5. So now split them up by the product rule. So split them up into 2 logs and add the 2 logs. Okay. So now we already have the amount or the approximation for log of 2, which is 0.3010, and then log of 5 is going to be 0.6990. Okay, so we're just going to add those up. So 0.3010 plus 0.6990 is equal to 1. Okay. All right, so now this one, 4, well, that could be 2 times 2. So we're going to do log of 2 times 2, then we'll split it up. So maybe by now you guys are kind of getting the idea here after watching a couple of these. So now it's going to be basically 0.3010 plus 0.3010. So we just add these together, and I can do that one. So that's 3 plus 3, and then that would be 0.620 0.6020. Okay. All right. So now the next one, how can I multiply to get 18? Well, I know 2 times 9 is log, but we don't have the log of 9. So what if I split it again? 2 times 3 times 3. Sorry, I ran out of room there. So 2 times 3 times 3, well, I know the log, we have the log of 2, and we have the log of 3, so I could do it twice. So now what we're going to do is we're going to split this up into 3 different logs. So if you have 3 numbers being multiplied, we can still use the product rule. So now it's log of 2 plus log of 3 plus log of 3 again. So it doesn't matter how many numbers you multiply, you can split them up. Okay, you can split them up 3 times, 4 times if you have 4 factors or terms. Okay, all right, so now log base of 2 is the 0.3010, and the log base of 3 is 0.4771, and I'll write that one more time, 4771. Okay, so we're going to add all those up. Oh, sorry, you guys can't see that. See, I put up the log of 2, log of 3, log of 3 twice. All right, so I'm just going to use this line because I already did 0.4771 twice and just add the 0.31010. Okay, and I get 1.2552. There we go. So again, you just, when you're working with all of these, let me get my head out of the way. You want to basically split up the number that you're given. You guys have 6, 15, 9, and 50. So you got to think, how can I multiply 50? 2 times 10, sorry, 5 times 10, and then maybe split up the 10, hint, hint. All right, the 9, oh shoot, we already did that one, didn't we? Oops, well, there's a freebie, guys. I already gave you the letter C. All right, if you want to practice on your own, don't look. Okay, next page. All right, so now this one, we're going to use that same product rule to solve the equation. Okay, so remember how I was able to expand the log when I had 2 numbers being multiplied? I can also condense it and go back the other way. So these 2 logs, which have the same base, remember they have to have the same base, Since they're being added, I can combine them into one log, and I multiply those numbers on the inside. So 3 times x equals 2. And now what I'm going to do is just put this in exponential form. So we're going to put it in this form, b to the e equals a. So base 4 to the e, which is the 2, equals a, which is the 3x. And now what I want to do first is I want to simplify that 4 squared, which is 16 equals 3x, and then divide the 3, and it's 16 over 3. Okay, and then remember, that's your guys' problem, so don't copy mine. All right, so now the next one, same idea, except now they're being subtracted, and when you subtract logs, you're using the quotient rule. So basically you combine them into one, but now you divide the two a values. And what's important is that the first a value becomes your numerator that goes on top, and then the second one goes on the bottom. You got to remember that. That's important. Okay, so now we'll use the same idea. We'll put it in exponential form. So now it's 3 to the 4, fourth power, equals 3 over x. What I'll do is I'll simplify that first. So 3 to the 4th, I know that one. You can always enter that in your calculator. 3 times 3 times 3 times 3, that's 81. Okay, so now it's 3 over x. Okay, so what I'm going to do here to solve this, I can do this a few different ways. I can multiply x times both sides. I can cross multiply. There's a number of ways you can do this. Okay, I'm going to use cross multiplication. And the nice thing about cross multiplication is I can just cross multiply here. And then divide by 81 would be my next step. The other thing I can do with other nice trick about cross multiplications is that I can switch numbers. So if I'm multiplying these two, I can actually switch the two, and it's still going to be equal. So basically what I'm going to do is I'm going to move this x to here and this 81 to here. And this is a useful trick, especially when we get to the next week's topic with cosine and sine, because you're doing a lot of cross multiplying with that. So basically I switch the x up to here and bring the 81 down to here. And then it's just x equals 3 over 81. And I'll show you why that's true, because basically if I do cross multiplication, which would be 81 times x, and then 1 times 3, and then the last step I would have done is divide by 81, and notice how it's the same thing. Okay, so I can just switch the numbers back and forth. All right, so now the next one. Here, I've already got the log is already like condensed into 1 on both sides. And remember, if you've got logs equal to each other, I can simply just drop them off. And now I just write the a's equal to each other. X minus 2 equals 5. Add the 2, x equals 7. Okay, you do that with yours. All right, now this one, I've got 2 logs on one side of the equation equal to 1 log. So I can't just cancel them until I only have 1 log on this side. So what I want to do is combine these two into 1 log first. And remember, it's minus, so that means I'm going to divide x divided by the 5. So the first a value divided by the second equals log base 2 of 3. Okay, so now I can cancel them, and x over 5 equals 3. And in this case, I could cross multiply, or here I can just multiply 5, since I have a number in the denominator. Multiply 5 both sides, and x equals 15. Okay. Hopefully you guys saw that. Sorry, I don't know if it was in the camera or not. Okay. All right. Now the next two. Okay, so here we've got an exponential. So we're going to get this back in log form, but before we do that, we got to get rid of this 11 in the front. So we want to isolate the base and the exponent. So let's divide 11 both sides. Okay, I know 11 squared is 121, so if I divide that by 11, it's just 11 here on the left, equals 4 to the x. And then we just put this in log form. The a becomes 11 equal to the x. And let's just go ahead and enter that in. To remember, for this one, in order to use Desmos, you have to use this version or this graphing calculator, because again, remember that the log function where you can change the base is not in the scientific version. Okay, so 1.729, and that 7 is going to round this 9 up to a 10, so that means I'm going to also round up this to 3, so 730. So x equals 1.730. Okay. All right, so now this one, okay, similar approach. Okay, we want to solve for x now because you notice there's a y and an x, so we got to simplify to solve for x. So first let's divide the 11 just like we did before. But now we have 11y on this side and x to the fourth here. And now this is a little different because the x is not in the exponent anymore. So we would approach that differently. So if the x was in the exponent, we would put it in log form. Okay, to get the x out of the exponent, but it's not. X is the base. So if x is the base, I want you to think about it. If it was like x squared equals 9, what would you do? You would square root both sides, right? Same thing if it was x cubed equals 27, you would cube root both sides, right? So if it's x to the fourth, we're basically we're gonna fourth root both sides. Okay, so that gets rid of the fourth here. So I'm gonna just switch the x to the left side. And now it's equal to the fourth root of 11y. So you end up with an expression. It's not like an actual value like this, okay? Just because there's an extra variable in there. And we don't have another equation, so we don't have nothing to like substitute or eliminate with. All right, so here, similar to this problem here, got to divide this number in the front first. To the x equals, if I divide this by 3, that's going to be 10.1. Okay, you can use a calculator if you need to for that one. And now it's log base 2, put in log form, of 10.1 equals x. Okay, and let's go ahead and solve that one in here. So now my log base function, we want 2 and 10.1. So we're going to round that. Let's see, it says to round to the nearest thousand. So we need 3 decimal places. 336, and that 2 is not going to change nothing. So x equals, I'm sorry, I didn't get it. So 3.336. Okay. All right, so now for this one, similar to this problem, if you notice. So let's divide that 4 first. And we get x to the fifth equals 6. And now here, since again the x is a base, we're going to take the fifth root this time and basically do the fifth root of 6. Okay, so I can do that here if I want, or I can use the scientific calculator. So I need to get a special function because I need the one where I can change that little number on the top. It's called the index, and that's going to be a fifth root of 6. So don't do square root. Square root's different. Remember, I want the fifth root. Okay, so again, we want to round to the nearest thousandth. So that's a 0. So that means that 9 is going to raise that to 1. So 1.431. Okay. All right, so the last one's here. Well, our x is inside the a value, so let's put this back in exponential form. So 6 to the power of 2 equals the a. So what I want to do first here is raise that to the power of 2. So 6 squared is 36. And now it's a pretty simple equation. Add 6, both sides, get 42. Then I divide by 3, and x equals 14. Okay. All right, so now here, remember before, like I said, I want to combine these into one log. Okay, since I have 2 logs on one side, and they're being added, so, and remember, it's automatically base 10 if nothing's written there, so I'm going to go ahead and write it in. And then it's going to be 4x times x, which is actually 4 squared, equals 8. Now, let me show you the difference between this problem, where I combined them here, and this problem, where I combined them here. Notice how I combine them, and I have a log on both sides. So that cancels the log. But when I combine here, I only have 1 log on the left, and over here, it's a number. So because it's just 1 log on that side, it's almost like I'm treating it just like this problem, okay, where I'm basically going to put it back in exponential form. So now it's 10 to the power of 8 equals 4x squared. And now to solve this, what I'm going to do is first, to get that x by itself, I have to divide by 4. Okay, now I can't divide 10 by 4 because I would have to do exponents first. Think about PEMDAS, right? Exponents before you divide. Okay, I have to, so I do not divide this 4 yet. Okay, so I need to like basically raise this to the power of 8 first. Okay, and actually what we'll do to simplify things so we don't get too confused, let's actually do that first. So 10 to the power of 8 means I have 8 zeros after I have 8 zeros. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, equals 4x squared. You're like, holy smokes, that's a big number. All right, now let's divide the 4. Now you can understand why I wouldn't want to divide 4, right? Because that would mess up the value. All right, so now let's go ahead and divide. How many? What is this? 100 million? Ooh. Okay, so 100 million divided by 4, that's going to be 25 million. Okay, so equals x squared. And now I'm going to take the square root, because that's a square, of 25 million. So big. I'm going to use this one just because it's clear. Square root of 25. Make sure you got the right amount of zeros. And it has 6 zeros, and so it's 5,000. Pretty simple, right? It's almost like kind of like the square root of 25, just with a lot of zeros. So x equals 5,000. You can do it. I know it seems like a lot, but you can do it. So again, combine the log, put it back in exponential form. Be careful, don't divide that number yet. You have a 2, I have a 4, and that's it.